Okay, geometers, welcome to the lesson on rectangles. We're going to get straight into it. So basically the objectives in this lesson are to recognize and apply properties of rectangles and also to determine whether a parallelogram or a quadrilateral is in fact a rectangle. So we begin with our definition of a rectangle. By definition, a rectangle is a quadrilateral with four right angles. Once we've established that a quadrilateral is a rectangle, we also know that it is a parallelogram because the rectangles have all of the same characteristics of parallelograms. Remember, that is not biconditional, and so just because something is a parallelogram does not guarantee that it's a rectangle, but if it is a rectangle, it does guarantee that it is a parallelogram. Of course, we can demonstrate very quickly why this is true. Once we have four 90-degree angles, we of course have both pairs of opposite sides parallel, and by definition that makes it a parallelogram, and that in turn gives the figure all of the characteristics of a parallelogram. Okay, and so there is one additional characteristic of a rectangle, and that is that the diagonals of a rectangle are congruent. And so you will recall, hopefully from the previous lesson, that the diagonals of a parallelogram bisect each other. The additional characteristic for a rectangle is that in addition to bisecting each other, they are equal in length. And essentially what that means is it results in four equal pieces. The diagonals are broken into four equal pieces, and this is a characteristic of a rectangle. Okay, and so what we're going to do is use these characteristics and properties in our examples. Okay, so first things first, we're told that segment JP is equal to 3y minus 5, and we are given that segment MK is equal to 5, let me just rewrite that, 5y plus 1. Okay, and what you can see, the obvious issue here is that JP is only a piece of the segment, and if we are to make an equation, then we need to modify the expressions that we've been given in order for them to be able to be equal. And so 5y plus 1 should equal, since MK is the whole of the diagonal, it should equal the entire length of JL. JP, using the characteristic that the diagonal is cut in half, of course, what we can do is take the length of JP, double that, and we will then be able to find y by setting up this equation. Okay, so in the interest of time, I'm just going to solve that off screen. Okay, and so what you can see is I've distributed out the parentheses, moved the y's to the right and the numbers to the left, and we have our solution y equals 11. Okay, second example is asking us to find the numbered angles. The given information is that this is a rectangle, and so immediately what we're able to do is to mark off our four 90-degree angles. Of course, that's our definition of a rectangle. The other thing that we can do is mark off the fact that the diagonals are congruent and, of course, bisected, and therefore we've got four equal pieces. This is of significance because we now have ourselves an isosceles triangle. And so actually we have isosceles triangles all over the rectangle, so to speak. That allows us to know that if this angle over here is 61, then angle 1 is also going to be 61 degrees. Measure of angle 4 can then be calculated using the fact that the angles of a triangle add up to 180 degrees. And I'm going to subtract 2 times 61. That's going to allow us to find the measure of angle 4, which will be 58 degrees. I can then use the fact that angle 3 and angle 4 are a linear pair, and that means that the measure of angle 3 will be 180 minus the measure of angle 4, which is 58, giving me an angle of 122 degrees. And finally, I can find the measure of angle 2 using the fact that angle 1 and 2 are complementary, add up to 90 degrees, and that of course is because the measure of angle DBC is a 90-degree angle, and so measure of angle 2 is 90 minus 61 for a measure of 29 degrees. Okay, we're going to move on to the next one, which is going to be a reminder of some algebra. We're going to solve this particular example algebraically. You are allowed the use of your calculator for this unit, but you will not be for next unit, and so to prepare you, we're going to do this algebraically. Okay, it is given, or rather, we're finding the values of x and y that make this a rectangle, and so we're going to treat it as if it's a rectangle. If it were a rectangle, of course, we have got bisected congruent diagonals, and that is going to allow me to set up the following equations. Y squared minus 3 is going to equal 3 minus y, and x squared is going to equal 3x plus 4. Okay, what I'm going to do is solve one of these on camera, and then I'll solve the other one off camera. So we're attempting to solve a quadratic equation algebraically, and so the first step is to equate to 0. So move all of the terms to one side of the equation. Then you can hopefully recognize this as a trinomial, and if you want to factorize a trinomial, we're going to open up two sets of parentheses, a binomial times a binomial. To get x squared, our factors are x and x. In order to get 4, our factors are going to be 4 and 1 or 2 and 2. In this particular case, we are adding and subtracting to obtain 3. And so hopefully that allows you to realize that the factors that we're interested in are 4 and 1. A minus over here tells us that we're going to have 1 plus and 1 minus, and we will know to give the minus to the larger of the two factors because we have a negative term in the middle. And so we end up with x plus 1 times x minus 4 equals 0. That means that x plus 1 must be 0, or x minus 4 must be 0. When the product of two numbers is 0, one of them must be 0. And finally, that allows us to get our two answers, minus 1 or 4 for x. Okay, and so I'm going to take you through the exact same process, this time solving for y, and I'm going to do that off camera. Okay, and so you can see I've moved all the terms to the left-hand side, factored my trinomial, and I have solutions of 2 or minus 3. What you need to be very careful of now with this example is that we need to check for extraneous solutions, and so what that means is we must substitute our answers back in to make sure that they are viable. And so I'm going to substitute the minus 1 back into the 2x expressions, and so minus 1 squared is going to yield a value of 1, and if I substitute minus 1 into 3x plus 4, I get minus 3 plus 4, which yields a diagonal length of 1. If I substitute the 4 in, so x squared, so 4 squared is going to give me 16. If I substitute that in here, 3 4s are 12 plus 4 is 16. And likewise, I'm going to do the same thing with the y values, substitute them in to each of the pieces. So y squared minus 3 is going to yield a value of 1. 3 minus 2 is going to yield a value of 1. If I substitute minus 3 into the equation, I'm going to get minus 3 squared, which is 9 minus 3 is going to give me 6. And if I substitute 3 minus minus 3, that will also give me 6. And hopefully what you've realized at this point is that the answers that we want, in fact, are y equal to 2 and x equals to minus 1. And both the minus 3 value and the 4 are extraneous. And the reason, of course, is because if the y value of minus 3 produces equal diagonal segments, but if this is a rectangle, the length of AB and the length of CD must be the same. And if we use the minus 3 value and the 4 value for x, we do not have diagonals that are congruent, and that means this would not be a rectangle. And so, in fact, only one of the x and one of the y values are appropriate solutions. And so you need to be very careful about that. Always sub back to test the legitimacy of the answer. Okay, moving on. We've now got a proof, and I'll try to move through this quickly. And so the given information is that triangle PSR is congruent to triangle QRS. We also have angle PSR is 90 degrees. Okay, and so what I'm going to do is start off by saying that the measure of, or rather angle QRS is also equal to 90 degrees, and that is because of CPCTC. Corresponding parts of congruent triangles are congruent, and you can see that angle S and angle R are corresponding parts. What I'm also going to do is highlight the fact that segment PS is congruent to segment QR, and that is also because of CPCTC. And my next statement is going to be that segment PS is going to be parallel to segment QR, and that is because the consecutive interior angles are supplementary. And so hopefully you remember the fun rule. If the consecutive interior angles are add up to 180, then the lines are parallel. And so since I was able to show that angle S and angle R were 90 degrees each, I can then conclude via CIA that PS must be parallel to QR. Okay, I've now shown that PS and QR are both congruent and parallel, and that means that PQRS is a parallelogram. And that is, if you recall from the previous lesson, one of the ways that you can prove a quadrilateral is a parallelogram is by proving one pair of opposite sides both congruent and parallel. And so that is because we have one pair of opposite sides parallel and congruent. And then what I'm going to do is use CPCTC one more time. I'm going to say that segment PR is congruent to segment QS. Also because of CPCTC, and so you can see here again, PR is going to be congruent to QS, and that is going to allow me to conclude that PQRS is a rectangle, and that is, of course, because of the theorem we learnt earlier today, namely that the diagonals of a rectangle are congruent. And so, or rather, if the diagonals of a parallelogram are congruent, then it is a rectangle. And so I'm using the converse of that theorem. And so in this particular case, that is because the diagonals of the parallelogram are congruent. And so once we know it's a parallelogram, if we prove that the diagonals are congruent, that proves that it is a rectangle. Okay, and lastly, in this particular case, we need to determine, based only on the given markings, whether the following quadrilaterals are best described only as a quadrilateral or as a parallelogram or as a rectangle, and we're providing the most accurate answer. So of course, anything that is a rectangle is automatically a parallelogram, and anything that's a rectangle is also a quadrilateral. Okay, so what I'd like you to do is have a go yourself at these, and what I'm going to do is complete these off screen, and then I'll come back and explain. Okay, welcome back. So you can have a look over here. Hopefully what you managed to conclude was that all four of these are rectangles. So very quickly I'll explain why. The fact that the diagonals bisect make it a parallelogram. The fact that all four pieces are equal then allow us to conclude rectangle. In this case we have three 90-degree angles, but hopefully you remember that the angles of a quadrilateral add up to 360, which means the fourth angle has to also be 90, and that by definition is a rectangle. Here we have one pair of opposite sides both parallel and congruent, making it a parallelogram. Then we have a 90-degree angle, and then of course you remember hopefully from the previous lesson as well that if in a parallelogram you have one 90-degree angle, you have four 90-degree angles, that of course confirms this is a rectangle. And finally, in this particular case, since these angles are 45 and we've got a reflexive side, these triangles are congruent to each other, which means all four of these sides are congruent, and that makes it a rectangle.